So first of all, a very warm welcome to all participants. We are very pleased that we have attracted the participants from Europe, from Asia, from even Latin America and United States. Welcome to this thematic workshop with the focus on the use of robots, drones, and satellites in agriculture. Today, we shall look into how agriculture in many countries is changing dramatically these years. Today's agriculture is in many countries being transformed into a high-tech enterprise that most 20th century farmers may have a hard time to recognize. Robots, drones, satellites able to automatically survey and treat crops may be the commonplace on farms in the future. The ultimate purpose of the use of robots, drones, and satellites is to optimize both from an economy, but also, in an environmental standpoint, and in some countries also due to the lack of skilled workforce. This thematic workshop will point out and showcase different solutions that are on the market and ready to be used by farmers worldwide. For this purpose, we have invited a number of brilliant speakers to give us an insight into this new brave world and to whether to conclude or not if future farmers are flying farmers. But before getting to the program, I have a few words about Global Foodture and the organizations behind it. So, Thomas, can you please change? The organizers of this workshop, is Food and Bio Cluster in Denmark and the ICT Cluster Innovation Technology Cluster from Slovenia. Go ahead. So this Global Foodture, in a nutshell, is a European COSME project and is designed to boost the sustainable transition of the food system worldwide through collaboration and innovation. That's a lot to take in, so we have aimed to stimulate innovation, collaboration between European SMEs and the Asian organizations in Japan, Singapore, South Korea, and Thailand. It's a huge task, so we have boiled it down to these themes, and today we focus on agriculture, but other themes: alternative protein, sustainable packaging, solutions to reduce food waste, and health projects. We do this over a number of activities. We have online matchmaking from this community platform you're on, the training programs for dedicated dates, and about 12 thematic workshops. And in 2023, we will be on site going to Thailand and Singapore as the target market. A few slides about the people, the consortia behind Global Foodture. You can see Food and Bio Cluster Denmark, Food Valley from the Netherlands, Flanders Food from Flanders, Pitagora from France, Food and Art Cluster from Spain, the Packaging Cluster from Spain, and the ICT Cluster from Slovenia. We are targeting, as we said earlier, Japan, South Korea, Singapore, and Thailand. And now we get to the program. I have been saying welcome, and now we start with the academia. We have invited the Associate Professor Henrik Skov Midtby from South Denmark University to talk about the experiences with the collection and use of data for precision agriculture. Please, Henrik, the floor is all yours.
Yes, I'll just share my screen, and
I guess I have to stop sharing, right? No, sorry, I'm not sharing.
I think I can take over.
Yeah, super,
I hope
thank you.
You can see my screen now?
Yes.
Fantastic. Good. Well, I'm an associate professor at the SDU US Center, where we work on utilizing UAVs for different purposes. And over the last years, I have been spending a lot of time involved in things related to agriculture, mainly in form of this project, the Square Meter Farming Project. And of course, we have collected a lot of experience from that project, and I would like to outline some of those for you. If you have any questions, then please put them in the chat, and we will take it afterwards or when it fits up. The square meter farming project is supported by the Danish Green Demonstration and Development Program, and was initially scheduled to run from 18 to 21, and we have gotten a single year of extension for that. Working with agriculture, sometimes the weather and the different things just hit you, and to that extent we needed one additional growth season to collect data, because the year 2018 was very dry, and in the project we would like to capture data about fungus infections from fields and so on, and when it's very dry you don't have these infections, so we got set back a year for some of the parts. The project is a collaboration between 3 private companies, a farm, and 2 universities. And the intention is to focus on how to gather data about the farm on a square meter level, hence the name, from different sources, for instance, from satellites, which we will have a presentation about a bit later, from drones, where I will be talking about this in just a moment, and also on the field robot level, where we will hear some experience from the farm droid afterwards. They are not part of the project, but we just have different elements of gathering information relating to farm fields here. At SDU, we choose to collect data using a UAV, and in this case we choose to use a fixed wing drone because it has a quite long flight time. The model we have been using, the Cumulus V1, and afterwards its upgraded version, the Hydron, has a 2-hour flight time, which means that we can actually collect a lot of data during that flight time and then get it back on ground, and we can then analyze the images afterwards. To use a camera mounted on a UAV provides us with a quite high resolution on the ground level, so maybe 10 or 20 millimeter per pixel, and that lets us resolve quite small details in the field. That allows us to monitor certain things that otherwise would be very hard to observe from, for instance, a satellite that have a resolution on 10 or 20 meters per pixel, or sight lengths per pixels. Some of our missions we flew with a multispectral camera, the Mica Centroid HM, and others were flown with a standard RGB camera. It has a bit higher resolution, but we have much lower spectral resolution, and I think Bjarke will address that in a moment. So what we have been doing with a standard flight was to drive out close to the field and then launch the UAV simply by throwing it into the air, and then it starts from the launch site and then circles a few times to gain altitude, and then it starts this pattern of flying forward and back across the field, and finally it goes into a descent mode and then lands towards the wind and simply makes what is known as a deep stall landing, where it goes up towards the wind, more or less stops midair and then falls down on its tummy. It seems a bit harsh to land a plane like that, but it has been designed to do so, so it actually works out quite well. When we are flying missions like this, we need to be in what is known as a visual line of flight, because these are the rules we are allowed to fly under in Denmark. So at all times we should be able to see the UAV or the drone from our control position. That also means we need to move from one location to a different location to cover the entire field. So there are some limitations on what is possible to do within the current legislation. But we have also contacted the TBST, the Traffic and Building Administration in Denmark, and got permission to conduct what is known as BVLOS flights. So we can actually launch the UAV from the A.T. Anderson Airport in a building and fly 13 kilometers out to the field, which is situated up here, close to Gyllenstein Manor, collect data, and then fly back again. And I should have a for this to be able, we need to close the airspace. That was one of the requirements from TBST for us to be able to do this. But then it allows us to actually conduct the mission without being able to see the drone at all times, so we can fly beyond visual line of sight. And hopefully I have a video of visualization of such a mission. So initially it's a launch from the A.T. Anderson Airport, and it's sent out in a few circles to gain altitude, as you can see. And then the first part of the mission, things like radio contact and antennas and so on are checked once again, and then it's cleared to take away towards the farm. And if you look at the map below, you can see that the route has actually been planned so we avoid flying above concentrations of houses. To, if something happens, then we will not have any issues with the UAV falling down on top of something that we don't want. Now the UAV is just moving forward and backward a few times across the field to gather images. And in a moment it will be finished with that, and then we can get back again. It will follow the same track, and now it has just been sped up, so we won't take that much time looking at it. And finally it descends and prepares for landing. And this is on the edge of what we are allowed to do in Denmark at the moment. It's not something we can do in the entire country, but I hope it will be possible to do this in some years' time. But it really requires us to have a good overview of what is happening in the air, so we don't have a collision with a UAV or other plane or whatever might be present up there. So now I hope I can get to the next slide. That's actually an issue here. That's a risk of using an embedded video.
No problem. Maybe try stopping the presentation, or now we see the Google, so
yeah,
you can go back to
then we can go on here. So what shows up here is after having gathered maybe 200 images of a single field, we will try to extract some useful data from that. And that usually consists of taking all the images illustrated by these blue plates here, and then stitching them together to one giant image of the entire field. And this is a process we can do in programs like either Pix4D or Metashape. So we can generate what is known as an automosaic. And an automosaic of one field could look like this. And it's not just one image, but it's one image with a very high resolution. This might be 30,000 pixels times 20,000 pixels in resolution, which means that we can actually zoom in quite much to a part of the field. And one aspect we looked into in the project was to actually count pumpkins, in this case, on the field. So we could locate where each of the individual pumpkins are placed in the field, but also say a bit about the density. How densely packed are they on the field? What are the number of pumpkins per square meter? And we can also say something about the size of the pumpkins to the farmer know both how many there are, but also where they are located in the field, which allows the farmer to conduct better decisions on how to actually harvest the fields and plan its sales and so on. So as input for this pumpkin counting application, we have images like this, where we have zoomed all in on the automosaic, and the program is then able to pinpoint the location of each of the pumpkins and present that to the farmer. Here I have illustrated with small red circles around each of the detected pumpkins. In some cases, they're just landing one by one, and in other cases, they are grouped in 3 next to each other, that it has also counted as 3. There might be a few errors around this, but it still gives you a pretty good estimate of the total number of pumpkins on the field, and much better than what you could do by just looking at a tiny part of the field manually. And it also allows us to generate illustrations like the one shown here, where you can actually see, well, what is the density on the number of pumpkins per square meter, not per square meter, but in 50 by 50 50 by 50 meter grids on the field. The numbers here have been divided by 100. So it provides us with an overview over the entire field. And pumpkins are one thing we could look at. We could also look at what is the distribution of plants that are not part of the seeding structure, that is the crop row. So what is the weed distribution in the field that can be used for planning when to use herbicides? And if we look at how much green material, that is how well the plants have emerged, we can also use that to plan how to use the fertilize the field in a proper way. So yeah, that was what we can actually do with the UAVs. There are also a few different other sensor platforms available, used in the project here. That could be either satellites, we have the drones and the field robots. If we go from the top, one issue with the satellite is that they have a quite low spatial resolution. That is, we cannot see individual plants using a satellite. And we're also sometimes limited by cloud coverage, which can be an issue in Denmark. It's not always you can actually see the field when the satellite is passing over the field or the area, and have the option of taking images of the field. But the good thing about satellites, and I didn't wrote it on the slide, but is you have a lot of spectral information that allows you to see how the crop is actually performing on the field, but you just have it on a much coarser scale. The drones also have issues. There are mainly 2 things here that are actually free. We have it's weather dependent, so we need a sufficiently good weather to be able to fly with the drones. If it's too windy, we cannot fly. If it rains, we cannot fly, and so on. And we also have a very limited weight of the payload because the drones have a limited carrying capacity. The total weight of the Cumulus V1 drone that I showed you earlier was 1.2 kilo, including camera. So it's not that much we can actually carry at that location. But we get a much higher resolution compared to the satellites, usually on the cost of having lower spectral resolution at that. And finally, we have the field robots, which are actually 3 or 4 wheel robots that are able to drive around in the field. This is the field surveyor, which was designed as part of the project. And it can take very high resolution images. It can carry a lot of sensors if we want to. It's not limited to a certain weight of payload. The platform here weighs 800 kilos or something on that order. So it can actually carry a lot of equipment. But it have a limited capacity because it moves quite slowly across the field, which limits how large a field it can monitor it at a certain amount of time. A few different field robots that I know of is the farm droid, which we will be introduced to a bit later. And we also have the body, which is built here in Denmark, which is able to navigate autonomously in the field and either collect data, but one of the benefits of the field robots is that they can actually do something on the ground. They can either control for weeds or conduct seeding operations or do other kinds of manipulations that a UAV will never be able to do, for instance. So I think I used my time here. Now we have a few minutes for questions. So if anything shows up, please let me know in the chat.
Yes, thank you so much, Henrik. And now the floor is yours. If you have any questions or comments to Henrik, please use the chat. So maybe I can start with a question. Henrik, could you say a few words about the farmers, what their reaction have been to all of a sudden introduce, not all of a sudden, but it's a process, of course, the robots and the drones and satellites. I can see the benefit, but one thing is the benefit. How are they receiving this new colleagues of theirs?
Yeah. First of all, it's not a standard farm we have been out to. It's Gyllensten Manor, and they have a very interesting owner that is very curious on what is possible to do with technique and to develop his company through these means. So he's very interested in all types of new technology and has tested out a lot of things. So he's definitely interested in getting new electronic collaborators or colleagues in the field if they're able to help him run a better business. But we also can see that it's not just sold as part of this project, because it's actually a quite tedious process of gathering all the data, doing something with it, and then provide it back to the farmer in a way that he can actually utilize to a good extent. We have had some good experience with optimizing the distribution of fertilizer in especially grass on or corn fields, not corn, but wheat fields it is. And we also got some information on, we provided information about the number of pumpkins and so on that he actually used to improving his sales. And back in 2018, the first year of the project, we got some feedback back on the pumpkins that he was able to sleep better at night, or the production leader out there could sleep better at night, and they sold 30,000 additional pumpkins based on our countings, because they knew what they were in the field and they could actually conduct the sales prior to Halloween, where the price of pumpkin seems to decline quite much here in Denmark.
Super interesting, and I love that you could actually go so closely to the pumpkins and see one by one, and of course a few clusters. Do you see it as a future for farmers, or is it far in the future or near future?
I think it's closer than we actually think. We have the option of actually gathering a lot of data, but what is missing right now is a good way of interpreting these images or whatever data is being collected, and then doing the last part of the transformation, so we can load the data into a fertilizer or a sprayer for herbicides and so on. So they actually use that in practice, and that part actually seems a lot more difficult than it should be, in my opinion, because every time I get out to a farmer and talk with them about why are they not doing this, then there are some incompatibilities between different pieces of software, and one type of sprayer needs input format in one specific format, and the other brands needs it in 3 different other formats, and they're just not standardized at the moment, which I think it would help if they could agree on every spray maps that should be used to control the spray should be in this format, and then it just works. Right now we have too many competing things to have that situation right now.
Thank you. Yes, it's a brave new world. It's not only the technique, it's also the behavior and the weather. You also mentioned the weather can be a disadvantage, for instance, with the drones and the weight, and the robots can be a bit slow, but yes, we're moving on, and I just wanted to know if anybody would like to ask Henrik a question. If not, then we will move on, and if you have any questions, then you can also send it to us, and we will ask Henrik to reply later on. And you will, of course, get all the presentations after the workshop. So thank you so much, Henrik, and super interesting. And if I was a farmer, I would definitely hook into these new technologies to improve the farming and saving and yield of the crops. So thank you so much. We will dig into a more concentrating on drones now. We have asked Andreas Kausika, the CEO from Hector Drone, to tell about precision weed control using the drones. So please, Andreas, a warm welcome. And you are already there, I see on the screen. So please go on. Thank you.
Perfect. First off, all of you can hear me, right?
Yeah, we do. Yeah, we do.
As mentioned, I'm Andreas. I'm from Hector Drone. We're a Danish manufacturer of drones. I'm very glad that Henrik went before me because he explained a lot of the problems concerning drones, concerning data collection. What we do is we make drones for industrial use cases. So drones for data collection of large areas. We carry different types of payloads for transport and logistics. And therefore, we are launching a drone into the agriculture market, actually on Agromec this year. So what we're looking into is making a drone for data collection, as Henrik mentioned, but data collection with different types of sensors and different tools on it. So if you look at drones today, we have like these three main categories: electric drones, tether drones, and hybrid drones. Electric drones, as mentioned, have a somewhat low flight time. They have high human interaction weight, so you have to go either throw it or put it out and then launch it and then sit there, look at it, wait for it to come back, and then you have to collect the SD card and put it into your computer, and you have to plan the mission and all that. There's a high interaction rate. And tether drones have the same issues. They don't have the issues of flight time. They have a tether mounted to them, but you can't go very far because they're tethered to the ground. And then you have hybrid drones, which is a drone powered by something different than electricity. They have a higher lifting capabilities, but you still have a somewhat high human interaction where you have to go and interact with the drone. So what we made is a universal drone platform. It can be used for many things. Now we're just looking into the agriculture segment. So we can lift 25 kilograms of payload for an hour, or 1 kilogram for 10 hours. It of course can be set up for different means. So we can lift a 5 kilogram sensor for roughly 6 hours. So we can do large areas. It can be configured with automatic refueling. It's not something we are launching it with in the beginning, but we have made like a docking station for it. We can go and dock and then land and sit there idle and wait. And then the whole thing is controlled and connected over 4G, 5G, which enables us to have a remote operator essentially setting up the missions, planning the missions, and pulling the data and then transmitting that data to our partners, which then do the analysis, and they then contact the farmer with the finished map. This removes a whole lot of the problems that you normally see where farmer either buys a drone or buys a service. When you buy the service, the upside is you don't have to do much, but it's very expensive. And the primary part of that expense is having a guy driving to your field with a drone or an ATV, gather a ton of data, and then drive all the way back again. The whole thing is powered by a generator. It can run on regular petrol, or we can run it on methanol or ethanol. And we have a SORA approved for the drone. And Henrik touched a little bit on this, the whole SORA thing. So what we want to do next year is we want to fly BVLOS over fields, and we can do so in very specific areas where we don't have to close down the airspace around the drone. And then it will be monitored by a remote operator. So we can do these gatherings of data without a guy actually standing there and picking his nose. So what we want to look into, Henrik touched on it again. So we want to do, of course, NDVI maps where you can see the health of the crops. It's a pretty well-known thing. You can do it from satellite. That's somewhat good enough for most use cases. And we then also want to touch into the actual weed detection part of it. So we mounted a high-resolution camera on the drone, and then we flew it at 3 meters height at around 15 kilometers an hour, and then it just, because we can go for so many hours, it doesn't really matter. And the drone has no problem like launching in the middle of the day or in the middle of the night. It wouldn't be compatible in this specific use case when you want to gather data, but for later use cases. So what we do is we take a picture, and then we have a good collaborator called AI Lab. Then we ship this picture to AI Lab, and they make a analysis on it. They can detect different types of weeds. This is just an example from one of our customers. And then these maps, we gather all the data of them, and then we can do NDVI maps with our partner Scout Robotics. The farmer will buy the drone, put it out, and then Scout Robotics will set up the missions depending on what the farmer wants. And then the drone will take off, gather the data, come back, ship the data to Scout Robotics, and then he will ship the data to the farmer and make sure it works with the tractor and the sprayer. So the initial phase, we'll do a test setup to make sure that you get the right type of map, and then from there on, you will just get an email with the map, and then you can load it into your sprayer. And then the more fun part of it is the weed maps, where you can see that's on the right here with AI Lab, where we can go in and detect the different types of weeds, and then you can allocate the areas and say, this is the area we have this type of weed in this concentration, and then you get a very nice map like this, where you have a green and a red area, and then you can essentially only spray the red areas, or essentially just tone down the spraying on the green segment, essentially giving you a healthier crop and a way cheaper operation. These are the things we are looking into. This is what we are very focused on, getting these platforms out there, and also being able to carry larger sensors like the soil optics, which is a 11 kilogram sensor, where you can do like earth analysis with it. So enabling farmers to have a tool that is at their place, so we don't have to fly from a central area multiple kilometers out and then inspect the field. The farmer can have his own drone, and it's just controlled remotely by a guy who knows what it is and how to use it. So that way, enabling the consultants to do a cheaper job. They don't have to drive there; they just have to manage it, and then enabling the farmer to get cheaper data and better insight into his field. What we're also looking into is we have a GDP-funded project called Crop Drone, where we're using our drone platform, and then Danish Agro and Danfoil, and then AI Lab and Scout Robotics and Aalborg University. We are the guys in this project, and we are building a sprayer on our drone platform. So essentially, we want to go and take the drone we already have now that can collect the data, and then collect the data, and then process it, and then send it to a spraying drone, which then goes and essentially flies these maps and sprays these maps from this data. So that's in essence what we're doing. This is the drone platform. It can be used for many other things, as you can see, but these are the areas we are focusing on right now. So collecting the data, and then in the future, spraying the fields from that data. That's the fastest I can do it. Hope there's some questions. Oh, no sound.
Yes, again, thank you very much, Andreas. It was hugely interesting. Are you concentrated on the Danish market, or you're looking for collaboration also abroad, or can you tell a little bit about your activities?
We're doing a lot in England and some down south, mostly also field inspections, but different type of field inspection. But this is launched primarily for the Danish market because it's our local market. But it could definitely be used other places in the world. Don't think fields discriminate. And also, a good thing to mention, for next year, at least in Denmark, you can get a subsidy if you use these plant detection tools. Just them.
Yes, I see in the chat, maybe you could tell a little bit about the soil optic. What properties can the sensor suit observe? And there's also a question, what's the relevant cost saving?
Yeah,
if you can elaborate a little bit.
Touching on the soil optics, that's just an example for heavier sensors that we could fly with in the future. We are not doing that right now, but we're in the talks. Essentially not having to drive this huge ATV around on a big trailer on a big platform just to gather some data. So using the drone for that instead. But the soil optics, for those who don't know, it's essentially you take a bunch of earth samples physically, and then you scan the earth afterwards with it's essentially like a big X-ray machine, and then you calibrate it with the real samples that you took, and then you get essentially a big map of how your earth looks in different areas. That's the short version of it. The relevant cost savings is essentially removing the guy out of the equation. So the man who needs an hourly salary, removing that person out of the picture, essentially cutting the cost in half for getting a drone inspection. And we believe that we can do it even cheaper in the future.
Do anyone have other questions? Please share the chat.
Oh yeah, what are the differences between the agri sector and the logistics? So the agri sector is primarily data collection, except when you look at the spraying part. But collecting data over a field where you're looking for weeds, or if you're looking for something else, it's essentially the same pattern you're flying, but it's just a different sensor. So the drone doesn't really know the difference of what it's doing. But when you look into logistics, it's more getting from one place to another. And then you need to carry a heavier payload, and that's where we can go up to the 25 kilogram payload for an hour, and we can go for roughly 50 kilometers an hour. So you can travel roughly 50 kilometers depending on wind speeds and stuff. So normally we carry 20 kilograms, and then we have a 5 kilogram buffer to make sure we can reach the target.
We have room for another question. Anyone? In the meantime, I would like to ask you also, we heard that Henrik talked about the authority, the regulations of how the drones can fly. Are you facing any issues with this? And I guess this is only for Denmark, but when you have been exporting also to the UK and other parts.
So it's EU regulation. So of course the UK's, they have their own rules now.
Oh, yeah, they have their own, yeah.
but it's EU regulation. Of course, you can use the same applications for different countries. You have to apply in each country, but the likelihood of you getting it if you have it in another country is quite high. And what we're doing is essentially what Henrik touched on is the fact that you have to close down the airspace. The problem in the authorities' eyes is not the ground, because if you're flying outside the city over fields, there's really no big issue if you crash, because the chance of you hitting something is very, very, very low. The problem is, how can you make sure you are not colliding with an actual airplane? That's the issue. That's why you close down the airspace, to make sure that no airplanes are near, right? And if you have a fixed wing drone, you have to close down a very big area, because if it suddenly cuts out, it can fly for a very long distance before it lands. So it essentially can travel for multiple kilometers before it touches down. So you have to close a very big airspace around it. Whereas a fixed wing, not a fixed wing, a multi-rotor, it will plummet directly down. So you can have a much narrower closing sector, and you can also fly at much lower altitudes. So you don't have to go very high. So if we travel below 30 meters and within 15 meters of obstacles, then we can essentially fly without observers, because then the traffic administration deem that we are not in violation of the airspace. Hope that makes sense.
Yes, yeah, that's flying farmers, maybe. Okay, Andreas. Sorry. Oh, gosh.
But yeah, please contact me if you want to hear more. There's shit ton more to talk about, but yeah, very limited time.
Yes, I know. This is also to give you a snapshot of what's on the market, and hopefully we can continue the dialogue on the platform. There are options to have online meetings if you're interested. Let's move on. Thank you so much, Andreas. It was very interesting, and another step to become a flying farmer. Let's continue. We have invited also Bjarke Jørgensen. He's head of the research at NewTech in Energies, and he's here to talk about the snapshot hyperspectral images for food science across multiple scales. And please, Bjarke, the floor is yours.
Thank you very much. So about hyperspectral imaging, I hope you can see my slides now. I'll talk about hyperspectral imaging, and the idea is to give you an introduction to NewTech, hyperspectral imaging in general, and especially two different types of principles for recording hyperspectral imaging: push broom and snapshot imaging. And then I'll give you a quick idea of what we are attempting to do with hyperspectral imaging. So NewTech was founded 45 years ago by Gunnar Petersen. We produce machines for weighing, packaging, sorting fruit and vegetables. We handle a wide range of products. Some of them are mentioned here. The two top most important ones are potatoes and carrots.
Björk, just to stop you a little bit, we don't see the slides moving, so just if I don't know if you're moving them or we just see the presentations listed. Yeah. So not the full screen and your slides. So
yeah, I was just about to say so. Thank you so much.
So you
maybe you try to share again the other screen, or if you have two screens, or
yeah, you're seeing a fixed one. That's
yeah. The first slide.
Only the first.
Yeah. No, it's good. Now it's good.
Now it's good.
Yeah.
Perfect. So hopefully you can see a list of products here. Is that correct? Excellent. And the top ones, that's potato and carrots, and that is the major ones for us. So more importantly, and that is we go into optical graders. We have more than 25 years of experience with optical graders. And the first one that was introduced to the market was the Astro in 1997. It had two alpha processors, which was supercomputers at the time, and it used artificial neural networks to sort potatoes. You have to realize in 1997, Google was not founded yet. Operating systems were installed from floppy disks, and the USB connection, as we know it today, was only 1 year old. So NewTech as a company is used to entering these technological fields at a very early stage. I mean, software engineers at NewTech were implementing artificial neural networks in the late 80s in order to do this. So what you see to the right is an optical grader as it looks today, the Silox. And let me show you a video of how this actually works. Here you see the potatoes entering the grader. What you see here is photodetectors that ensure that the potatoes are correctly separated. And once we're inside the grader, the potatoes go onto rollers, so we can image the entire surface of each potato using the QTech cameras that you see up here. I'll get back to these cameras later on, but each potato is imaged somewhere between 13 and 100 times. Once the potato's been imaged, they go on to the spinnerflex, which is where the actual sorting takes place. The spinnerflex has small fingers that can be released, so the potatoes drop down to a conveyor belt underneath, depending on the size, shape, quality of the potatoes. A grader like this can handle, or a sorting machine can handle somewhere between 25 and 30 tons of potatoes per hour. And for instance, size and shape can be sorted with an accuracy of 1/10 of a millimeter if needed. The heart and soul of this machine is actually the camera. It's manufactured by our daughter company, Q Technology, and it's a smart camera referring to the process powers in the camera. We have integrated CPU, GPU, and FPGA. So all the data analysis is actually done in this camera. At the same time, it's a modular camera, so we can change the sensor depending on the applications. And it's actually this that is the platform for our development of hyperspectral cameras. So what is a hyperspectral image? You can consider a hyperspectral image to be a stack of images of the object that you're looking at, in this case, potatoes, at each wavelength or spectral band. Compared to an RGB, in an RGB image, you only have 3 spectral bands, red, green, and blue. In our hyperspectral images, we have somewhere between 100 and 1,000 spectral bands, depending on the configuration. Hyperspectral images can be recorded in multiple ways, but in general, we can talk about 4 principles of recording: whisk broom, push broom, spectral scanning, and snapshot imaging. Whisker broom is often used in laboratories where you need high precision in both spectral and spatial resolution. However, it's not suitable for industrial applications, or at least not inline. So I'll only focus on the push broom and the snapshot in this case. For the push broom, we have an object, we have a lens for focusing, and then we have a spectrograph. In the spectrograph, we have a slit, so we're actually only looking at one line of the object. The light from this line is then diffracted onto the image sensor in the camera, so you have a spatial and a spectral axis. Let me try to explain this a bit. We're looking at an object that is moving, or that could be a drone that is moving, and then you have the ground stable. But in this case, we're looking at a conveyor belt with a color check on top. We then look at one line at a time, and here you see the what is actually collected on the camera, the frame, and that's the diffracted light. So we have a spectral axis and a spatial axis. We record this frame, look at the next line, record this frame, next line, and so forth. So we scan the entire sample. We can then take these images and merge together into a 3D data structure, and that is actually the hyperspectral image. From this, we can either cut out a spatial plane at a given wavelength, or a spectral plane at a given direction in space. And the analysis of hyperspectral imaging is actually combining the different bands, like in this case, the red, green, and blue band, and you get back to the RGB image as we are familiar with. I can also give you an example where we look at a hyperspectral image. We see image each band. Here we look at a piece of paper where we wrote Foodture using different color markers. And we also wrote some text using a pencil, covering it with a black marker. And as we start to get into, we start to be in an area where the sensor is actually sensitive, you'll start to see the letters flickering as we move into ranges where the dye is no longer absorbing the light. And at some point, we actually get into a range where even the black dye is not absorbing. And you can then see the text that was underneath or that was covered with this black dye. All these images are recorded using our Foodture setup, which is this one. It's a commercial product suitable for ad-line applications or research purposes, but the camera itself could be taken out and mounted on a drone or a satellite itself. Satellite is a little extreme in this case. So we look for defects in products, and we can actually separate that into 2 kinds. We could either have the case of fungus and soil that's common, that we like to distinguish fungus and soil that's on the surface of the potatoes. So there we're just looking for contrast. Or it could be an internal defect underneath the peel. The issue is, if I was going to show you images of this, you would just see odd-shaped blobs where we separate one blob from the other. However, if we were looking for letters or hidden text, you would be able to see if we could find the text. And the first case is actually from the University of Southern Denmark. They have a large collection of medieval books, the Herluf Holm collection. And at that time, parchment was reused, and all text was erased, so it was no longer readable, and it could be used, this parchment could be used for binding or for new text. However, the old text could not be recovered, but it can be done using hyperspectral imaging. The other alternative is if you have text that is actually inside a sealed envelope. And it's actually two different cases. You can compare it to the first one to a colorblind test like this Ishihara test, where we're looking for a contrast. The other one, we actually have to go through a layer. We will have scattering, and we'll have to look at variance and actually do a bit of a physical trick, changing the frame of reference, but I'll show you that. In the first case, we just have to go to the right wavelength and the text becomes readable like this. When we did this the first time, the librarian who helped us find these books, he could actually read this text like it was a comic book. And 80% of the text that we recovered that day was completely unknown. So they continued that work afterwards. For the envelope, the sealed envelope, is a bit different. We look at the variation in the scattered light, and then we do a principal component analysis, and we can actually recover the text that is hidden on a letter inside. Now, that is push bloom. More interestingly, in this case, it's maybe the snapshot imaging. And here we have to do a diffraction in two directions. So we actually get 9 projections of the hyperspectral cube, and then do a reconstruction in order to see the hyperspectral cube. There are methods to do that. So if we look at a potato with this type of fungus that I referred to previously, then what you see to the left is what we actually have on the collector. In the center, you can see the potato and you see some large black spots. That's actually one of these funguses, but you can also see the freckles. If you look at this standard expectation maximization algorithm we used, you'll see all kind of artifacts. It actually looks horrible and it's hard to distinguish anything real. So we have a collaboration with the University of Southern Denmark, and we found a way to use artificial neural networks to do this reconstruction. And if we compare, here you see the EM algorithm, and to the right, you see the reconstruction using artificial neural networks. And here you can even distinguish the fungus from the freckles. So this is a really fast technique, and it can be implemented directly on the camera. And I am happy to show you the next slide, because that's something we've really been working on. Got it? This is the last thing I want to show you. Hyperspectral movies. We are recording with 14 frames, cubes per second. You see 100 spectral bands. And that is our intention, to bring that onto drones and satellites. Thank you for your attention. Any questions?
There are no questions so far. Anyone come forward, please? Yes. There is one question. What is the weight of the setup? And one more thing, what research needs are there to bring this wider in the food industry?
Let me start with one. Right now, the camera is about 1 kilo. So that would, according to the previous speaker, give us about 10 hours of flight time. However, the camera is not optimized for drones and satellites yet. And that's the reason why we're interested in this. It's simply to be better at developing this technology. And the third question was, what research needs are there to bring this wider in the food industry? Hyperspectral images like this, and that would be a whole nother talk, can be used for measuring starch, sugar, water content, some amino acids. We also have bacteria detection, so we can actually detect some of these diseases at a very early stage. We can detect toxic compounds and so forth. So there's actually a large range of bringing this into food industry in general. We can see a lot more.
I wish we had more time, but I think we have to move on. And thank you so much, Andreas. It was hugely interesting to see what's possible, and another step to the maybe improving the flying farmer. Next, we would like to invite Eddie Boulding Peterson from FarmDroid. And he's here to talk about the world first fully automatic robot for both sowing and weeding. So Eddie, are you ready?
Yeah, are you ready, Eddie? I heard that a couple of times.
Sorry, I couldn't
during my
resist.
life.
Sorry.
That's good. 1 second, I will just share my screen. Do you see my presentation? Okay,
Yeah.
perfect. Also, yeah, first of all, thank you for having me and giving me the opportunity to tell you a bit about FarmDroid and what we do. So to introduce myself, my name is Susanne said, Eddie Bolding Petersen, and I'm the head of sales and marketing at FarmDroid. So I started at FarmDroid back in the spring of 2020 when we were still a very young company. I'll get back to that a bit later. So first of all, just to give you an overview, I'll just first give you an introduction to FarmDroid, what we do, the product we've developed, and then I will end up by telling you a bit about where we are today development-wise as a company. So first of all, for all farmers, if you are working within agriculture, one of the biggest problems is, of course, weed control. And research suggests that up to 80% of yield can be lost due to lack of weed control. And when we're moving away from more and more chemicals or when we're moving away from using more chemicals in agriculture, then what we're left with is, for now, organic agriculture. And for organic farmers, it's really a big struggle to handle weed control. So if you look at a picture like this, it probably doesn't take an expert to tell which on which field the highest yield will be. The field on the left, of course, is what we could call insufficient weed control, and on the right, what we would call FarmDroid weed control. So the field on the left was really an actual field where they were doing testing close or next to the field on the right. So just to show that if you don't take care of the weeds, then they will simply take over and the crops won't have a chance to grow. So our solution to this is the FarmDroid FD20. Just at a glance, then the robot it's a seeding and weeding robot. I will get back to that on the next slide. But the robot is completely solar powered. In late spring and in the summertime, solar energy is actually enough for the robot to run 24/7. So the robot will, the energy from the solar panels will of course be used for running the machine, but it will have, it's efficient enough to store the extra energy, so it will be able to run during nighttime as well. It's meant to run 24/7. It will go slow, as you will see on the video on the next slide, but it's meant to run 24/7. And of course, all of this chemical free, and obviously you can control everything from your smartphone. So just to show you a bit of running videos here. So as I said before, the robot is a seeding and weeding robot. So instead of using cameras, we are using RTK, simple RTK GPS. One of the issues with camera systems is that what we found was that when you do, if you transplant vegetables, cameras work quite well. But if you seed something directly, like a sugar beet or onion, it's very difficult for the camera to distinguish between the weed and the crop. So after seeding, the robot will remember the position of each individual seed. And as you see in the video here, the robot knows exactly where each individual plant is located and can then move on to do the weed control both between the rows, but also in between each individual plant. It's a little bit difficult to see here, but the robot makes like a perfect grid on the field, and you will, no matter what direction you're looking, you will be able to see these lines of crops standing with the exact same distance. We have a precision on our RTK of around 8 millimeters because we use a local base station. The seed, of course, can roll a little bit, but normally we have this precision of ±5 millimeters of the seed where it should be located. Oh, sorry, it's restarting. One of the advantages with using, with us doing the seeding ourselves and remembering position of the seeds is that we don't need to do any crop recognition. So we started out with sugar beets. The robot was really developed for sugar beets, but we just 3D print different seed discs, as you see on the picture here below. So we just test different seeds, and then a farmer would simply send us a small bag of seeds, parsley for instance, and then we would test that at our place, make a seed disc that works exactly for parsley and send that back to them. So we had farmers who bought a machine for sugar beets, send us a small bag of some other crop, and then within 2 or 3 days he had the seed discs for another crop. Until now, as I said, we have tested more than 75 crops. Some of them, for various reasons, is difficult for us to handle. But right now, we have more than 25 different crops in our library for seed discs. So for farmers, the benefits are that the obvious benefit is to save manual labor. So farmers, they can save up to 94% on time spent on manual weeding. Farmers, they would have these big weeding crews walking around. It's not only very costly, it's also very difficult to find labor to that for that kind of work all over the world, really. Farmers, they get an increase in yield of up to 40%. The reason probably is we're looking into this more and more, but because we know the position of the seed, we can start the weed control the day after seeding, meaning that the crops will never really have any competition from the weeds, and thereby getting a higher yield. So actually, we have some organic farmers now that starts on these row crops like sugar beets to start to actually be comparable to conventional farming where they use herbicides. Then, of course, we enable farmers to going from have, as I said before, these big weeding crews. It's one farmer we have in Germany. He had normally has 100 hectares of organic crops, which he would normally manually weed. He would have a weeding crew of 30 to 40 people. Now he's just him and his one employee, and then they have 4 robots to do the weed control. And it's of course not to it's not our goal to replace manual or to replace labor forces, but it's just getting really increasingly difficult to find this kind of labor, as I said before. And then lastly, for something like organic sugar beet, organic onions, vegetables in general, there's a really good business case for the farmers. So some of them, they paid the machine back in less than 1 year in the money they saved. Then lastly, just to give you an idea where we are as a company, so FarmDrive was really made for farmers by farmers. You can hear that's a marketing slogan, obviously, but farming is really in our DNA. So Jens and Christian Warming, who founded FarmDroid, they both grew up on an organic farm in Denmark. And Jens, he was responsible for doing the manual weed control back in 2011. And I think after a couple of days, he had enough of this walking around the field doing the manual weed control, and he got the idea for the robot. So the FarmDroid as a company was founded in 2018. We had our first prototype. We launched a new, the first, you could call it somewhere in between the 0 series probably, the FarmDroid FD20 version 1.0. We launched that in Denmark in 2019. Sold 12 of those in Denmark for testing and starting the commercial development. In 2020, we launched the FarmDroid FD20 2.0, which is more or less the same model as I've been showing you just now. We had a 900% revenue growth, and we started selling in the countries as you see here. We're already present in Denmark and Scandinavia. Started selling in the Netherlands, Germany, Switzerland, Austria, and then late 2020 in France. And by 2021, we were in this field robotics area as to what we know the world's biggest in number of machines sold. And then this year, by 2022, we have managed to every year have this growth of around 100% in sales, and really sustained our development just through sales. So now today we have sold more than 300 machines and now working commercially in the field. Just very quickly, we have our own production. Everything is assembled in Denmark, designed and assembled. We are now, as I said, when I started in 2020, we were 5 or 6 employees. We are now more than 50 employees, growing all the time, operational in more than 15 countries and more than 300 units running. Thank you. If there is any questions, just feel free to write me an email or reach out by LinkedIn or phone or something.
Yes, thank you so much, Eddie. It was hugely interesting, and also the fact that it's running on solar energy. It's more the global green transition. So, and you can see at the rate that you are growing, it's something that the farmers have taken in. So hopefully you'll be worldwide. Maybe Asia is the next step, and we are now also welcoming questions for Eddie. We are running not so much behind, but there are room for 1 or 2 questions.
Yeah, maybe we can also take it in the chat.
Yes,
yeah,
there's
okay.
one. What is the business model?
Yeah, so today we've been fortunate and you could say good and fortunate to sell the machines. So that's how we do today. We're moving more and more into the service aspect of things as well. So we have actually a support farm care team sitting 10 people monitoring all the machines. So we actually try to, if there is any issues with the robots, we try to solve that before the farmer gets some info about it. So we're trying to move because you need some kind of recurring revenue, of course, if
Yes.
for future, right? But yeah, so far we've been fortunate to sell the machines directly through distributors to farmers.
Any other questions before we move on? It doesn't seem
I will
to
stop
be.
the sharing, Susanne.
Yeah, so well, thank you so much, Eddie. I know you're a busy man. When I called you one time, you were in Italy on a trade fair. So there's a good opportunities for a lot of sunshine there and selling the machine. I hope you managed to get some good contacts. And as I said, next step may be Asia.
Yeah,
So
definitely.
this concludes my part from the workshop, and I would now leave the floor to my good network colleague, Tomas, from the ICT cluster. So thank you so much for now. I'll be back later.
Okay, thank you, Suzanne, and thank you, everyone. So yeah, we are now moving to the second part of the workshop. So from basically from the ground or to a little bit higher to the space, so to say. So I will not, have too much words because we are running a little bit late. So I will give a word to a colleague, to Panagiotis Ilias from Ilvo, who is basically a senior IT business analyst. Ilvo is a Flanders Researchers Institute for Agriculture, Fisheries and Food. So Panos, yeah, please, the floor is yours, or the screen is yours.
Hello, good morning. Can you see my slide?
Yeah, it's good.
Okay, very nice. Again, good morning to all, and thank you for the invitation. Not only because it provides me with the opportunity to present today ILVO activities and best practices related to using satellite data in agriculture, but also because until now I had the opportunity to see very interesting presentations. And I wish some colleague of me to be here today, but I will share the presentations with them because at ILVO we are dealing also with drones, robotics, but also running the food pilot unit. So all the presentations are relevant. My name is Panos Ilias. I'm a researcher at ILVO, as Thomas mentioned, which is a Flemish Research Institute for Agriculture, Fishery and Food, linked to the Flemish government. And in the last few years, my main research topics have been related to smart farming, agricultural data sharing and data spaces in agri-food and soil, the design and building of platforms like Just Connect, and the building of Earth observation AI-based services, supporting the monitoring, but also the optimization of various agricultural activities. Additional, since this year, I'm leading the Big Data Value Association Task Force for Agri-Food, which is a sector-specific task force with a mandate to enable the digital transformation, not only in agriculture, but also fishery, aquaculture, and other systems like the food system. I will start my presentation by setting up a little bit the framework because, as Thomas mentioned, I have to speak about satellites, a little bit different, and as a way also to help you understand better how does the food and agri-tech industry relate to the technology and the space sector, how does the space data enable agriculture, and which role have the actors, also the farmers, in the Earth observation value chain. I will start with some facts. The first one is that if we look at the 30 technologies of the next decade, we will find that most of them are being used until now in agricultural applications. Additionally, and this is something it was obvious from the previous presentations, the technology industry keep up with high growth rates. And let me give you an example of a specific technological industry. It's the space industry. As you may see, it plays a role in many non-space industries, including agriculture. And in agriculture, there is to support the monitoring of soil, irrigation, prediction of yields, many different applications. In this slide, it's coming from a McKinsey report. You can see that the satellite cost performance radio for medium resolution satellites like Copernicus or Landsat, but also for the high resolution satellites, has the last 15 years has been increased by 3,500% or 300% for the high resolution satellite. That means that the radio of the end value to the actual cost has been improved, and this is compatible to the computers, and it's a parallel is the transition from mainframe to desktop computing we have in 70s and 80s. This is something that we need to have in our mind. And also another thing is that there is a value chain in Earth observation that support the value chain, support the passing from raw data that the satellites collect to data products and consulting services. And this value chain also is applicable in agriculture. It's similar. And there we used to, in Earth observation, to distinguish between the upstream and downstream. Today I'm going to speak mainly about downstream and not about the upstream. In these value chains, the actors have roles. And in the downstream, the intermediate users are mainly Earth observation experts, which means they are scientists, engineers, domain experts, and their goal, their aim is to generate added value for the end users. The end users usually are not members of the space community, they don't have to. And also it's critical that to know that I guess all of us know that dealing with remote sensing, that they have tailored needs. I mean, every time the situation is different, especially in agriculture. And this is a challenge we have to face. In a very recent report, just 1 week ago, there's a lovely visualization that describes the value chain, its actors, and different categories of end users. And there, the farmers are end users. That's the position of the farmers. Together with, and mainly we have to speak with them, and together with agricultural consultants, the agronomists, because from my experience, the farmers are more close to the agronomists, not to the data scientists or the researchers. They spend their time, their day, their years together. They are facing the issues. There is more trust between them. And in this value chain, we also have the information providers. That's terminology. It's the one who's trying to develop products or services, and they support the modern farming. And the modern farming, we know that it also relies on Earth observation data, GNSS, drones, robotics, and the goal is to have sustainable nutrition management, restoring soil health, present biodiversity, but also to improve the crop production and to support the farmers. It looks like, based on the reports, that the Earth observation, the GNSS, it's a promising investment. They double the revenues, and annually, or sometimes in 10 years, as we saw in the previous graph. We have many scientific achievements that are being published every day. If you go to the Google Scholar, you find many publications, new things that the scientists have discovered in hyperspectral, big data, neural networks, and we also have policy forces that wants to support the further adoption and the exploitation of the satellite data. That's the landscape. However, even if the insights from the reports generate a positive picture, we must remember that there is an adoption issue. It's something that we know, and I'm not going to explain why, but I will bring the position of the end users and the farmers, and those, they have questions. Some of them I already have been presented related to the technology. They want to know about the accuracy, the technology issues. It's related also to their position. How can I get started? Is it applicable for me? Those are things that you will hear if you start interacting with the farmers. And also it's about financial investments and the benefit they are going to get when, but also the position, their position, and how the transition, because every time we ask them to perform a transition, to adopt new technology, and this is not something new for them. They know this for the last 30 years, how that will reflect their position, but also the relation with the other actors in the value chain. So we know that there is a need for end user involvement and participation in the development of Earth observation data, products, and services. And this is critical not only for the big companies that exist there for many years, and they also have revenue from other industries, not only from agriculture, mainly from the defense industry, but mainly for small companies, for SMEs, for startups that in Europe, they represent the 93% of the Earth observation company community. And the questions we have is how we can bring together the end user, the technology providers, and other actors in the value chains, and how the Research Institute support this process. As Silvo, we are trying to use as tool for that the Living Labs and the Digital Innovation Hub. You are using co-creation cycles and an agile approach, starting from awareness, moving up to the development of MVP products, and end up to evaluation in real life settings, with attention not only to technical, but also to economic, social, and economic aspects. So stakeholder engagement, it's critical, but another element that is useful is the project, the research innovation projects. And there, if you put them all together, they create a roadmap. The projects are stops in this innovation roadmaps, or important elements of the puzzle, because they provide us with new insights about technology, and it's also a way to erase new questions and proceed further. A project that is coming from this approach is it's a targeted project we had this year and last year. The goal there was to federate an FMIS system, a farm management information system that mainly uses Earth observation satellite data, has been developed by Vito, and a data sharing platform developed by Ilvo called Just Connect that allows the farmers to expose their data, but under control. I mean, they have to provide their consent, and also they have to know, they will know for which application for their data will be used. And that's a project that is an answer to the farmer question, what about my data? It's a critical question related to data sharing and this data sovereignty of the farmers. For the last part of my presentation, I will speak for briefly present the development process we have for satellite-based services using the Envision project, which has been started 2 years ago. Yeah, in September 2022. The mission, our mission as Ilvo, is to develop a service that delivers topsoil quantitative soil organic carbon estimation at parcel level. And there the goal is to cover needs coming from the Common Agricultural Policy at European level for soil organic carbon monitoring in croplands. The idea behind, in a very simple way, was if we assume that there is a relation between the reflectance signature coming from a bare soil surface with the soil organic carbon content at between 5, 0 and 15 centimeters, is it possible to model this using the reflectance values coming from satellites and especially from Sentinel-2? And if so, can it be applied at large scale? And under which condition this information will be useful for the end users? We develop a methodology that has different phases. I don't have time to explain more, but there it's important to distinguish the scientific, the phases that related to the scientists, the modeling using machine learning or the infrastructure we develop in order to handle more than 6,000 satellite images, but mainly about the deployment of this information, the business logic behind the data products, and how we can validate together with all the actors. That's these data products. That's a map of topsoil organic carbon map in Flanders, can support regional monitoring, but also can provide information to the farmers at parcel level, and can also present the intravariability of topsoil organic carbon. Are those products that I presented the end of our activities? No, we still have to do things, not only to find sustainable ways to increase and ensure the accuracy of the products without risking the main weapon of Earth observation, meaning the optimum cost accuracy level, but also to support the decision making of the policy makers to see how we can integrate the service with existing infrastructure. This is about interoperability and the fact that the farmers, also the paying agencies, they have to deal with many IT systems, and it's difficult for them to maintain different SLAs, to integrate, to perform data integration and infrastructure integration, how we can reuse the products. And also how about upscale? The latest, together with the fusion of data from different sources, is a challenge we deal with in another project that will start at the beginning of next year, called Scale Act Data. There, as Ilvo, we're leading the co-design process, and together with significant actors of the Earth observation community and with the end users, we will work at different verticals: crop, soil, livestock, air, by using satellite data together with in situ sensors, hyperspectral imagery, and see how we can upscale the products, how we can create services that cover bigger scale. Thank you. Maybe I was 1 minute more in my presentation. Sorry for that.
No problem, no problem. It was a great. So yeah, and thank you, Panos, for the excellent presentation and giving us an overview of what is possible within the satellite data in the agricultural space. So I would propose that we maybe, since we are running a little bit late, and I want to stick to the time frame. So I propose that we take some questions in the chat, and maybe Panos can then answer it through chat, and maybe we have a small question and answer session at the end, just to keep it within the time limit. So I would move forward with the next presentation. So we have Monica Satchev, who is basically a project manager at Listenfield, which is an agtech company based in Japan and Thailand. So, and she will be speaking about how they are using the satellite data within their company. So Monica, floor is yours.
Thank you, Thomas. And first of all, I'd like to really thank you and your team for inviting me to speak today and giving me the opportunity to explain about our company's product. As for others, hello, my name is Monica. I am from Thailand and my company is Listenfield. I'm actually a project manager for my company. So I'm a representative to talk about what my company does and how our products are related to the satellite and how we help farmers in Thailand. For today's agenda, I'd like to introduce a bit about my company, about the satellite usage in our products, and our farm AI management system, which we use to help farmers and cooperatives in Thailand produce more yield in the crops. So my company is actually founded by Dr. Rasurin Chinato Thiranan, who's Thai, and Dr. Kiyoshi Honda, who's Japanese. In 2017, they co-founded Listenfield and took the work outside of the academic field. So Dr. Honda was Dr. Rasurin's professor, and then Dr. Rasurin studied with Dr. Honda, and they realized that they could do so much more than just being in university and running small projects. They wanted to make the product come to life. So after 2 years, Listenfield received the UNDP Low Carbon Award, and which proved the environmental benefits of machine vision, which applied to the purpose of precision agriculture. We are still receiving the investments. In 2020, Listenfield's API became a part of the Japanese government's agricultural reform policy. In 2021, Listenfield received investment from Kubota to expand the network. And today, Listenfield is a growing company with multicultural team of around 20 people in the operations team, operating from around 6 countries, and more than 20,000 farmers using our technologies in Thailand and in Southeast Asian region. So in Thailand, we are right now working with sugarcane. Mainly the crops that we are focusing on are sugarcane, rice, sweet corn, cassava, and potato. And in Japan, we are working with mainly rice, potato, soybean, wheat, and sugar beet. So these are some crops that we are mainly focusing on right now. As for our system, so for our company, we believe that there are 4 key areas of solutions in the agricultural industry. One is the agro data collection, one is improving the farm management. Another is modeling scenarios and predictions, breeding more and better crops faster. And our company's products and services are not just standalone solutions, but it is interconnected into an ecosystem which bring value to one another. So our main technology is our farm AI, farm management system, which is our dashboard. In our farm AI, we use satellite images from Sentinel-2 to calculate vegetation index such as NGVI, the normalized difference vegetation index, the EVI, enhanced vegetation index, and NDMI, which is a normalized difference moisture index. And these indices are shown to end users as images for them to see how their fields are. So today I'm going to explain about our main product, which is the Farm AI management system, which helps farmers and corporates in reducing field operational costs using satellite images and also other data, and supporting farmers and cooperatives in effective productivity management and helping maximizing the investment in farming. So before I go deeply into the NDVI, NDMI, and EVI part, I'd like to give an overview of how our system works. Can you see my screen?
Yeah, we do.
Okay, so this is called the Farm AI management system, which we're using in mainly Thailand and Japan, and also other Southeast Asian countries. We have companies who work with farmers with scattered fields around the world, and if they have fields in different provinces or different countries and it's hard to manage, using this system they'll be able to get an overview of all the fields that's under their organization, and they'll be able to manage it better and more effectively, knowing which field to focus on and which field to give more time to. So on our overview page, we help in predicting the yield of the crops on a monthly basis in tons. So we actually have the predicted production and actual production, and companies can also adjust their targets per month, like what their target would be on how much yield they'd expect on each month. We show the total actual production in ton, and we calculate whether it's above or below target. And we also provide the average yield in tons per hectare. And we also prove whether it is above or below target based on the calculations. Over here, we can also filter the information according to the years. If we want to focus on 2020, 2021, or 22, or any past years to see how the yield has increased or decreased. We can also filter the months, the countries where our crops are, and the crops that we want to focus on, or the crops yield that we want to see. On the right-hand side, on this table, you can see the total crop zones, that how many crop zones are in this dashboard and how many were added in 2022. So we can see here that there are around 44 more fields, crop zones added in 2022, which is 120% higher than last year. We can see the number of farmers using our system, and we can see how many has changed in the past year. And this part is actually very important to most of the agronomists in Thailand to be able to check how many hectares are there in total in the organization, how many hectares are bare lands, which is the gray color, and how many hectares are under cultivation. On this map, we can see the numbers 59 and 1 or 2. We can see how many fields are rare. So if I zoom into the 59, I can zoom in closer and find the fields that my farmers are planting. So on this page, this is the overview page that help agronomists or farmers manage their fields on a daily basis. As I zoom in, I can see all the fields scattered, and all these fields are under my organization. I can click into it and see the scores on our monitoring page. So we can see the true color of the fields. We can see the soil and fertilizer part. We can see the vegetation score, the NDVI with a scale to detect which crop zones are healthy and which crop zones need to be focused on. We can see the historical data of the NDVI on how much it has changed, and we agronomists can figure out and see which parts they need to focus on. And below here, there's a graph to show the VI score after days after the plantation. We can also see the moisture score, which is the NDMI, to check the water stress. Since in Thailand there's a lot of flooding that occurs, it is useful for farmers to detect which area of their land are lacking water and which area has enough water. And we can also check the biomass score or the EVI on our dashboard. On our dashboard, we also have the crop zone board page where farmers can check the crops, the crop variety, we do crop ranking, we can check the planting date, harvesting date, and the actual production or the yield. We can also check the harvest production, harvest yield, and we can also track the traceability of the crop quality, harvest destination, and the income that farmers have. And most importantly, we can also check the performance, the growth rate, and the actual yield and the predicted yield of the crops in our dashboard. So these are few things our Farm AI dashboard can do using the satellite images. We do not only have the Farm AI dashboard, but we also have a mobile application for farmers to log their farming data, the weather data, the community. They also use the Farm AI mobile application to do community machine sharing, similar to Grab, on how you rent machines and harvest it in the fields. So these are a few things we do in our company. And if you'd like more details or if you have more questions, you can contact me and I can provide you more information on what our technologies can do. Thank you very much.
Thank you, Monica. That was interesting. Lots of things happening there. So yeah, so if anyone has any questions, please use the chat or also get in contact with Monica maybe directly so she can explain it more into details. So yeah, sorry, I have to move to be able to stick to the timeline. So we have a next presentation coming up from Erwin Csöke, who is basically a business development manager at World of Space, which is a Czech Republic-based company. So Erwin, I hope you are here and you are able to share the screen.
Yes, I'm here.
Thank you.
I'm sharing my screen. Can you see my screen?
Yeah, we do.
Great. So thank you for the invitation in this nice webinar, first of all. And yeah, so we are a company from the Czech Republic, World from Space, and we are from Brno region, the region of IT and space technology that is famous from. So what we are doing, we are basically satellite data experts. We are working since 2017, is the company established, and the headcount is 12 people. So it's not small, not large. We like to say that it's the right amount of people to make difference, and it is also easy to change the direction and focus on what is important. So our key aim is to helping other companies to use satellite data in which we believe that is making change and increasing production, reducing impacts on the environment and also in many things. And also and also to understand the food production is how it's going on, and to prevent food shortages, high prices, and so on. So as we are working with the companies, we are also working on research and development projects with the European Space Agency, as with local universities, and we are also consultants at the European Union Space Agency program. So briefly, that was about us. So which satellites we are using? Basically, we are working with the Copernicus program. So we are using Sentinel-1 and Sentinel-2. So we are using radar active satellites and also the passive hyperspectral ones. So the resolution of them is the spatial resolution of Sentinel-1 is down to 5 meters, and the SAT is up to 400 kilometers, and it's available every 2 up to 3 days. And of course, it's not cloud independent. So, and then we have Sentinel-2, which is so the resolution is depending on, it's more for vegetation and water related monitoring. The spatial resolution is, it depends on the particular spectral bands, but the most often used are 10-meter resolution. And the data is available every 2 up to 3 days in Europe, but it's affected by clouds. So, and also we are currently gathering users to test, and like clients also to test the Planet satellite data integration. That is our plan for the future. So digital agriculture is about integration. So what we do here, we provide basically one piece of the puzzle in this system. So drones, satellites, Internet of Things, they are not rivals. So we are also looking for partners to work with, to combine this data and to get as precise things as we can. So I like to say that this satellite part is the least precise part of the precision agriculture. And if you combine it with more and more precise parts, you are getting very precise data, which really makes easy the data decision, the decision making. So the usage of the satellites, at 2021, it was 15%. As we know, the people and the industry was using satellite monitoring in agriculture, and 85% were not using. Some predictions are saying that 2025, 85% will be using satellite data monitoring and 50% will not. So basically we are end of the 2022. As we visited now CIMA in Paris, it was a great proof that their satellite monitoring and generally satellites inside agriculture are very used too. So as for variable rate application, as for combination with other things. So these are opening totally new revenue streams as the other prices of the inputs and fertilizers and also the water problems of these days are big. This is providing like a, let's say 15 up to 40% decrease in the inputs due to variable rate applications, which is also becoming a standard. And also like 5 up to 15% increase in yields if we are making the right decisions. 5% doesn't sound big enough, but like 5% of the US soy for a year, it can feed the whole Mexico. So it is globally a very big amount. So actually what are our functions and what Dynacrop does is crop monitoring. So we are having current and historical state of the field in 10-meter resolution as the Sentinels are launched in 2017. Also time series. Based on that time series, we are having graphs and also field analytics where the farmer and also the agronomist, they can follow how it was the before stage and how is it now. So many for controlling and also many other benefits. Application maps, so the variable rate applications, what I was talking about, so fertilizing, seeding, soil sampling is a great thing on that. The variable rate applications can be calibrated, it can set up for zones, so it can be used for many purposes. And also the soil moisture, that is one of our things what we are monitoring by the Sentinel-1. Also our products, so we are not providing red, green, blue images. We are an index-based service, so we are having 19 type of indexes. I will not go over them because we are short of time, but just feel free to ask me about it later and we can have a meeting. So our inputs, yeah, so what we are requiring actually is just field polygons, and based on that we can provide 10-meter resolution maps, histogram, statistics, metadata, geotiff, color geotiff, PNG maps, and so on. So these are basically in pictures like what we do. So observation, zonation mixers, some of our functions, so we can set up zonations on a couple of years summarized, then current state, 1 year state, all of that we are doing a zonational mixer, and we are setting up zones for the certain activities. Also statistics and histograms, and as you can see here are the time series. So that is also based on 5 years, so we can follow every activity in the field. So this is basically from our front-end application, one part. We are monitoring here is the soil organic carbon, which was monitored before the vegetation was on the field, and then we set up a zonation map for bigger, for a longer amount of time, where it shows similar spots that where the soil organic carbon was lower, there basically the vegetation is also like lower, the biomass by the NDVI. This is some of the pictures how we are actually working with it. So we have the picture, then we are having a raster format, and then we are vectorizing it. This is for soil sampling we were doing, for example. Also the soil moisture index, the time series, how we can monitor, for example, we're combining by climate data. So this is the participation and how the participation is connected with the soil moisture. Also for, we are providing a QGIS plugin, which can be for if someone is more familiar or likes to use software. QGIS is a great software for it, so you can gather data. You can gather our data also from there. So this is a link to our documentation, as we will share the presentation, so you can feel free to explore more. And why Dynacrop and this satellite data? So it's super easy now with our help. Satellite data is not anymore a complicated thing with us. So the implementation is fast, and we also guide our partners through the process. So more innovation and collaboration. It is growing with companies in the digital farming market and serve their specific needs. And it's all the time having R&D projects ongoing, and which we are also sharing with our. So the pricing is also great. It's super friendly, and real satellite data expertise. As we are working in the field of satellite data, we are having knowledge not just for agriculture but also for other things. So we are really willing to share it, and customer support that I was already mentioning. That we are guiding our clients, also our partners, and yeah. So the integration of satellite data is basically to heal the bleeding scars of your field, as it's a large-scale monitoring, so you can see many other things inside what's happening. And thank you for your attention. That's it from me. And yeah, if you have any other questions, as we are short from time, you're welcome to contact me, and I will be more than happy to present you more about our solution. Thank you.
Excellent, excellent. Thank you, Elven, and thank you for the presentation. Yeah, I liked that one, that presentation with the pieces of the puzzle. Yeah, if we could mix all the presentations together today, we could find a perfect solution for future of agriculture. So from robots to drones to satellites, so yeah, that would be great.
These kind of webinars are helping us in that, and
yeah,
very nice also to hear all of this from the colleagues before. So.
Excellent, excellent. So yeah, if everyone has a question, so yeah, you can put it in the chat and everyone can answer it, or you can also book a meeting, of course, with him. So, and yeah, we are moving slowly to the final presentation. Last but not least, Alessandro. So Alessandro Saetta is a CEO of Terra from Space. So it's a startup company from Italy, and yeah, Alessandro, the floor is yours. So take it over.
Hi everyone. Can you confirm you see full screen?
Yeah, we do.
Great. Good morning, everyone. I'm Alessandro Saetta. First, thank you for having me. It's great. It has been great to see all the wonderful presentation and also to share our experience. So, starting from the problem Terra from Spain is tackling. Here we talk about the impact of climate change on agriculture. This impact has many effects. Most of them relevant on some areas, and can be translated in a reduction of yields and quality of the final product, against for the farmer themselves an increase in running costs in the field to actually balance these climatic shifts. So within this macro sector in Terra for Space, we decided to focus on viticulture, since it's a huge market, strategic market for Europe specifically. Vine trees are high valuable crops, and the wine industry is truly undergoing a global geographic disruption. So within this scenario, our approach follows an adaptation strategy against climate change. We want to support a resilient viticulture planning through a data-intensive approach, and we want to safeguard both traditional wine regions that have been producing for many years and in some cases are now suffering, and also areas that are actually benefiting from climate change and are starting to become quality wine areas. So our solution is reliant on Earth observation data mainly and AI, and is a service to detect unexploited planting sites optimal for the creation of new vineyards. So the aim of this service is to reduce primarily the risk and the cost for investment, which is huge when you actually set up a new vineyard, and also since to return from the investment of a vineyard, you need to produce for many years, and everything has to be properly planned. And also, of course, through the constant monitoring satellites allows, we want to also increase the quality of the grape for wine and guide the farmers to a sustainable management. So, as said, satellite are our main data source. Currently, we're using Copernicus, Sentinel-1 and Sentinel-2 dataset to train our model. On top of this layer of data, we also integrate in situ data. And importantly, we exploit a climatic projection to actually estimate trends on relevant environmental parameters for the problem of under study. So we want to make sure that if we pinpoint a site, that site will be stable under certain condition and will allow the farmer to produce sustainably also from the financial point of view. So the outcome of this service we are actually developing will be the identification for the area under study of some sites, and also we are trying to build a model capable to match the local condition of the site in terms of soil and climate with the most suitable vine variety, also in accordance with the regulation which for the wine sector are a lot actually. So customer segment for us are wine producers, but also wine consortia, which are mainly interested in understanding on a regional level how the situation is developing, because wine consortia are actually changing the regulation, the laws, to try to actually adapt to all this changing scenario. This is valid for terrestrial space, but also for many other application we saw today. The Earth observation market is huge, is actually booming. And the coolest thing is, I think, the set of application is huge. Today we talk about agriculture, but there are many other sectors Earth observation can support. Within the precision viticulture, which is our niche, we have some competitors, but those are indirect. They provide useful mitigation services. So they monitor existing vineyards and they provide with short-term measures to support the farmers. We can do this, but our main service is strategical. So we want to support decision in the medium to long-term time frame, and we focus on new sites or the renovation of old sites. So sites that have been producing, but local conditions are too degraded that vineyards needs to be grabbed up. So either we suggest another variety, or we even suggest a shift in terms of crop due to the newly local condition. The team is pretty small. This is a young company, a young startup, and we try to form this team having a mix of technical and business competence, and of course the wine domain knowledge is relevant internally. So we founded a company in Italy end of last year. Now we have been supported by some programs. The most important thing is we validated the value proposition with the customer, so we are sure what we're building is asked from the market, and we have a prototype now. We are actually piloting with few producers in the Mediterranean area in Europe, but we are open also for collaboration and test with other producers even in other countries. For the medium to long-term strategy, we want, I mean, to have an impact in different countries where actually wine making is allowed and can be done. Also, some other customer segment could be of interest, could be the insurance sector, because it is tightly linked with the winemaker. And we are building the model to be scalable to answer to do the same, to mirror the same service to other high valuable crops. So to conclude, I just wanted since I'm aware there are some Asian attendees, to drop this small call for action. So here are listed the 3 important Asian countries where viticulture is actually present and is actually growing. Those are hectareage surfaces covered with vineyards. Those numbers are from 2021 and trends are positive. So vineyards have been increasing in terms of areas. There are some peculiar conditions in these countries since those are subtropical or tropical climate areas. So in this case, site selection is even more crucial, plus mitigation measures, so the monitoring allowed by satellite. So just to say that we would be glad to talk with anyone also from these countries, because this would allow us to actually end the development of a product you know, with better accuracy and being able to answer to different problems. With this, I thank you for your attention. Here is my email if you have any question. And again, thank you for having me.
Thank you. Thanks, Alessandro. Great. Yeah. If anyone is interested, of course, yeah, we are still having the chat function also open. So, and yeah, of course, you can be contacted within this email or also through the B2Match platform, which I guess Suzanne will take it over and present a little bit more. Suzanne, you want to share a screen or should I?
I think I still have problems with the changing of the slides. So if you can go all the way to the wrap up and closing, then I can just make a few conclusions. Well, first of all, thank you to all the brilliant speakers. Our aim with this workshop was to give you an insight into how robots and drones and satellites can be the help of the future farming. Takeaways are exactly that future farming can become more efficient, the less use of fertilizer, more yield, more control. So someone said that the farmers are sleeping better at night. That's also good. But in other words, it's to optimize and through precision farming. So also we hope that this presentation can boost the sustainable transition of the food system, a production system also, and also enhance innovation through collaboration. And this is what I'm going to talk a little about, because this project, the Global Foodture, is to get to know each other a little bit better and to see and showcase the technology, the state of technologies and products. And we have seen that today, immensely interesting. Our next step, so to speak, is also to focus on each country. So our next event is already on the 30th of November, and the target is Thailand. So if you want to know more about Thailand, how to do business, and afterwards also to have dedicated matchmaking. We have matchmaking all the time, but especially on the 30th and the February and in April and September, we'll have more dedicated countries matchmaking. So tune in, go to the web. You will also receive email on this, but go to our community platform to learn more about it. So also the next, please. We have another workshop. We altogether have 12, and we're coming in December 8th to the workshop that is more concentrating on the reduce of food waste, how you can or companies can valorize the food waste either produce a new project of the food waste with added value as high as possible, also from the side streams technologies. So you can also go on the community platform to see all the topics of the workshop, and you will receive this presentation. You can just click on the whole overview of this catalog. Just a few words on the matchmaking. The whole community is, you have a profile before the event, maybe on the 30th of November, go in and see if you can improve your profile, fill in the marketplace, what are you looking for, what are you maybe offering, and then look through the participants or in the line of marketplace, and then use the filters to find some relevant meeting partners. Then you can request or be booked for meetings. And of course, hopefully the counterpart will accept it. And if not relevant, then you're also entitled, of course, to say no, thank you. Then the meeting would be scheduled for this time, the 30th of November, but you can do it throughout the entire project time, and that will be ending till the end of October next year. And then, of course, prepare for the meeting, have a look who is you're meeting with, and then have the meeting on the day you have scheduled. As I said, the long-term, next one, please, Thomas. Yeah, the long-term means that now you have met some online, maybe you want to learn more about them, and you don't have to wait till November. Then go in and book the meeting for yourself, and then hopefully when we go to Thailand, then you already have met some, and it would be a great help already to prepare yourself for this, and later on for Singapore, but also for the 2 other countries that we are targeting. So all in all, if we have any questions, please send emails or go online and talk to the participants on the platform. And as I said, all presentations will be sent. Also, this recording will be listed and uploaded on the community platform. So for those who want to share it with colleagues, you'll be able to. Then I think I will say thank you again for all the really great presentations. I am very, very impressed, and wow, who had thought that we could use robots and drones and satellites for agriculture? And this is just to show that the mind of the human being is beyond this world. So Thomas, would you like to also say a few words?
Yeah, basically just yeah, saying thanks to everyone who joined, who presented their solution. Yeah, there's a new world coming up, I see, and yeah, it is a pleasure to be part of it. And yeah, let's see what we can come up with. So yeah, I guess farmers will be there too, and they need support from us. So yeah, it will be a challenging, but yeah, we are used to that. So looking forward to the next steps. So thank you all, and yeah, stay in touch anyway.
Yeah.
So
thank you.
Thank you. Thank you.
Thank you.
Bye bye.
Thank you. Bye.
Bye
Bye bye. Bye bye.
Bye.
Bye bye. Thank you.